There's been an ongoing debate about what is a system. So what we're going to do today is we're going to see if we can resolve that debate by talking about which system are we discussing. I'm Joseph Kasser, and
I'm Bruce Lerner.
the topics we're going to talk about today are the undesirable situation is the different definitions of a system in the literature in this ongoing debate over the years. So there is no consensus on what is a system. Yeah, the assumptions I'm making are there is a valid reason for the different definitions. FCFDS is that we understand the reasons for the different definitions and we get a consensus on what is a system. Before we get to the FCFDS, we have to infer the FCFDS. Before we do that, we have to understand the context in which the definitions were made. Before we do that, we have to look for the common elements in the definitions and the specific differences in the definitions. Before we do that, we have to collect a reasonable sample of definitions. And so the solution for how the what was done was examine the definitions and use critical thinking to infer conclusions. So we're going to do this logically, not emotionally. So Bruce, some of the discussions on the definition of a system have involved jet aircraft. So, is this the system?
Yes.
Or, Bruce, is this the system?
I guess it depends. So what is the system?
Well, I looked at that problem 20 years ago. I examined 51 different dictionary entries for the word system in Webster's dictionary. And then I looked at 21 different publication definitions from 1963 to 2004. And here are the authors and the citations. And I'll read some of them to you, or we can read them together actually, Bruce. The first one, an array of components designed to accomplish a particular objectives according to a plan.
A set of concepts and/or elements that are used to satisfy a need or a requirement.
An assemblage or combination of components or parts forming a complex or unitary whole.
A number of elements and their relationships between those elements.
A set of different elements so connected or related as to perform a unique function, not performed by the elements alone.
The model of a whole entity. When applied to human activity, the model is characterized fundamentally in terms of a hierarchical structure, emergent properties, communications, and control. An observer may choose to relate this model to real-world activity. When applied to natural or man-made entities, the crucial characteristic is the emergent properties of the whole.
A network of interdependent components that work together to try to accomplish the aim of the system. And here's another sample of definitions, but we're not going to read them. But you can see that one is from Stafford Beer, another is from James Martin. There's the Nkosi definition in 2002. There's Stuart Arnold's definition from the first edition of the ISO 15288 standard. Well, let's comment on the definitions, Bruce.
There are two different classes of definitions shown. The first is a set of definitions that describe generic systems, and the second is the definition specifically applied to engineered systems.
So a system can be anything we choose. This is Klein's definition. The choice is wholly and absolutely at the discretion of the person doing the analysis.
Thus, the definition of a system is much like the view of words expressed by Humpty Dumpty in Lewis Carroll's Through the Looking Glass, when he said, "When I use a word, it means what I choose it to mean, nothing more and nothing less."
So it is with a system. It is just what you or I or anyone else doing a study say the system is. And that's the reason for the different definitions in the literature and the continuing appearance of new definitions.
So, will the dispute continue into the future?
I hope not. Let's see if we can resolve it. Looking at the context in which the definitions were written, each definer was not defining a system. Each definer was using the word system to describe the system, namely their system of interest. And that's just what you or I or anyone else doing a study says the system is. And that's why they're all different. There's a key concept here. English grammar uses the word a for a general object and the word the for the specific instance of the object. So there's a difference between the system and a system. So what's the difference between a system and the system?
An agreement on a definition hasn't happened yet. A candidate definition based on the core commonality in SOIs is a system consists of three related sets: a set of elements, a set of interactions between the elements, and a set of boundary conditions, which was proposed by Aslaskin and Belcher in '92. The system of interest. The object of study, what we want to discuss, define, analyze, think about, write about, and so forth, was defined by Klein. Our choice of boundaries and interaction depend on what we are trying to understand and what we, as engineers, want to achieve by this understanding. So that system of interest definitions are inherently subjective. In effect, defining a system of interest is the first step in creating a model of some part or aspect of reality, and that was Atlassian.
So here are the common elements in a system, and the drawing comes from Flood and Jackson in 1991. So Bruce, is this the system?
It can be the system, yes.
Or is this the system?
I guess this could be the system too.
Or is this the system?
I'm beginning to see why there's so many different definitions. So Joe, which is the system?
Well, you've actually asked the wrong question, or you poorly phrased it. What you should have been asking is, what is the system of interest? And let me explain that. Let's take a look at the hierarchical view showing the pilot, the plane, the ground crew, and the other subsystems in the same level in the hierarchy. If we're interested in the plane, the system of interest is the plane. If we're interested in how the plane is used, then the system of interest is the plane and the pilot. If we're interested in how the system is maintained, then the system of interest is the plane and the ground crew.
So let's use another example. Let's think about a camera. There are a couple of different ways of thinking about a camera. One is using the camera to capture images. The SOI, in this case, becomes the camera and the operator and whatever is being photographed. We have to think about transporting the camera. So the SOI for this is the camera, the operator, and the camera case. And if it's a digital camera, we have to think about recharging it. So we now add the camera, the operator, and the charger as another system of interest. And then we get to the point where we actually want to be developing and designing the camera itself, which is engineering rather than analysis. So we have to understand how a camera is going to work. So the SOI in this case is the camera, and we're concerned about its contents as functions and components. So we start by taking a look at the camera itself and realizing that there's a boundary associated with it. And this is an external view. We have to take a look at how we interact with our subject. And we have to realize that we're a part of this system. And if we're going to be carrying it around, we have to understand how a case is going to be interacting with the camera and ourselves. And when it's time to charge the camera, we have to do something with it, and it has to interact with the camera. And there may be other factors that have an effect that need to be considered, even though they don't directly touch on the camera itself, such as the power source that the charger is going to be running off of, or the light source that's going to provide illumination to the subject. So when we're looking at the capturing images system of interest, even though all parts of this exist that we just discussed, we're now only thinking about the subject, the operator, and how the camera interacts with those other elements. So if we're taking a look at transporting the camera, we're interested in the case and how the operator interacts with the case and the case interacts with the camera. And when we're charging the camera, we're concerned only with the charger, the operator, and the camera itself.
So, in summary, we've discovered the reason for the dispute. Many of the definers are using the word system for their system of interest. They should be using the word system of interest. Some of the benefits of the discovery include understanding different system of interests helps manage complexity by using different systems of interest for different problems. So we can abstract out parts of the quote system that are not applicable to the particular problem we're dealing with. Appropriate system of interests helps manage complexity by bounding for specific problems. And now it's time for Andre to moderate the discussion. Over to you, Andre.